Thank you very much, Ben, and thank you all for joining us today, joining me. Actually, I'm really excited to go right after Matt because a lot of what he's talking in policy is, say, a little more general, and I'm going to get a little bit more granular on where we're going with some sustainable materials courses and beneficial reuse courses at the University of Florida. And so I'm going to talk about that stuff now. And so a little bit what we're talking about, I'm going to get into this word ESSI and what that means. Some ideas of what I'm doing with research and course development. So I'm going to talk about research. I'm going to talk about the courses born from that research. Some themes for sustainable materials use or management, considerations, case studies, and some future initiatives. As you know, ACI is moving very much into reduced carbon, sustainability, and so on. And Matt, who just finished up as the chair of the Low Carbon Code Committee, and we have a lot of sustainability committees and so on. So we know that ACI is making strides in this area. So a little bit about ESSI. That is the Civil and Coastal Engineering joined with Environmental Engineering at the University of Florida, which becomes the Engineering School for Sustainable Infrastructure and Environment. I don't know why I have that abbreviated improperly. And so basically we got a few departments together, and we now have what is a school. And so a lot of folks working on this and a lot of students involved. And so when we get into sustainable materials management, I'm going to talk a little about one of my mentors and professors in environmental engineering, and that's Tim Townsend. I'm obviously in civil engineering, so we are doing some, say, cross-pollination as far as sustainability, especially when it comes to development of research projects and development of courses. Tim and I have worked on, I don't know, somewhere between 8 and 12 projects over the last 10 years, and we've produced a lot of good research, a lot of good pubs, and so on. And so the two courses I want to talk about today are Beneficial Reuse of Waste, which is an environmental engineering course, and that was created by Tim Townsend, and I've taught it once so far, and then Sustainable Materials in Civil Engineering, which I've taught 3 times. So what we do at UF is if it's a graduate level course and it's relevant to our students, we'll usually do a 2-year revolving window, so that course is available to grad students who want to take it every other year. So we get our PhD students this information. And so in the learning objectives for 6525, which is the Sustainable Materials course, that's a civil course, we have use of materials in CE and construction, the definition of sustainability, which is actually very important as we're getting into a lot of what we're doing with sustainability, production materials, recycling and beneficial reuse. So there are some crossovers between the classes, like I said. Trade-offs with respect to use of sustainable materials, LCA, sustainable engineering practices, and there are a lot of other things in there. I can't obviously go over an entire course in a single slide, in a single lecture, so let's not try and go over 2. But the second course is an environmental engineering course, which is beneficial reuse of materials. And so for this one, we get into the use of materials, effective replacement for commodity, legitimate use, and the solid waste arena, and then a practice that involves that in sustainability. Okay, and so this is a slide I've used a few times in lectures, not only like with my class, but also with industry, with stakeholders, with cement producers, and so on. And so again, some of the themes for SMM are how are we going to define it? How are we dealing with life cycle and embodied energy, which I think for the concrete industry is going to become very, 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 very important as we compete with other materials and so on. Building materials role in that sustainability, SMM, and then obviously concrete's role. And I'm going to talk a lot about resilience. That's kind of the silent aspect of concrete that really gives us the win when it comes to beneficial reuse, sustainability, and green materials, as Matt pointed out in the previous lecture. So what is SMM? It's basically a key component for development of sustainable infrastructure. And this was basically put forward by the EPA about 10 years ago now, where they wanted to see the measurement of success of materials through the US based on waste generation and disposal. Okay, so we're talking about waste materials now. And so we're working on an effort from materials management, which focuses on a reuse rather than just straight up disposal. And so when I think of that, I kind of get a little bit cynical when I look at this truck, because it'd be nice to know what we could do if everything was used again, as they dumped that in a landfill. Sorry about the reverb. Okay, so when I think of building technologies and some of the themes we have in our class as well, I get into what do we actually do when we construct something out of concrete. And so we have an extraction process, we have a processing, manufacture, and And then we have distribution and use. And this is kind of what we do when we build a road, build a building, and so on. And then as we get into LCA and we start getting into this cradle to grave initiative, we see that maybe we have some disposal, and then if we're lucky, we get a little bit of recycling going on. And that's pretty much, if we're going to go from cradle to cradle now to cradle to grave, cradle to grave to cradle to cradle, we have a new cradle, which is our recycled materials, we see two types of processes. And so I can give you a whole list of ASTMs and ACI guidance documents that tell me what I must have. I mean, if I have aggregate gradation that's a little bit out of place, that material is going to be rejected, even concrete trucks and so on, out of temperature and so on. But then when I get into recycling, we don't do the same level of, we'll say, scrutiny and control. And that's one of the things I think our industry needs to do. The folks that are involved in beneficial reuse have to do. And so I really want to see how we focus on that moving forward. And I'll talk about a little bit of a case study we've used. Obviously, portions of the class are related to Portland cement concrete, where we talk about the basic ingredients. I'm going to have to talk about that in this room. But what I do want to do is talk about when we get into beneficial reuse. So there are a couple aspects to this. So when we have a residual, we have our typical ingredients, our cookie in the last lecture, and then we have a manufacturing process and a new product. And so one of the things that we've been doing, and we actually have a lot of, we'll say, traction on this, is using materials as a manufacturing new ingredient like SEM or or alternative kiln feed. And right now there are a couple of producers in the state of Florida using waste to energy ash, which I'll define and talk about in a little bit, for kiln feed. So we're taking what would normally be something thrown in the landfill and bringing that out and making Portland cement out of it. And that's my cradle to cradle. So we're resurrecting materials from the grave and bringing it back into the cradle. And the second is if we have something that's maybe more of an additive in a concrete material, right? And so we have typical ingredients, and we're going to go use something, maybe a recycled aggregate, slag, and again, I'm going to talk about one material in particular. And so when I get into thinking about our considerations for SMM, we have our structural adequacy we have to think about. Durability, obviously, is key. Economy, everything, if we're not going to have economy, no one's going to use it. And then there's an environmental risk. And Matt talked about he talked about risk in the last presentation, and environmental risk is a big portion as well. What if this stuff happens to leach a lot of arsenic into the landfill or into the aquifer? Are we going to be able to use that material? Probably no one's going to want to use that. And so we really do have to kind of hit the sweet spot with a lot of what we're doing with SMM. And I'm very optimistic that we're, one, able to do that and doing that. And obviously the impact of each of this will vary for different materials. The other thing I want to think about when I think of the Portland cement concrete industry is we have a very long history of SMM. I just don't think we advertise that well. I almost feel like in the last decade or so, a lot of folks have come across and said, well, like Matt said in that last one, concrete's bad. It's a CO2 producing material, and you guys are the devil of all industries creating any materials for construction. And my rebuttal to that to start off is, well, we've been using recycled materials for over 100 years now, which is not far off from the patenting of Portland cement itself, right? 50 years later. So I say we are the actual original folks that are into green concrete and so on and so forth. And obviously we've used fly ash to the point where we're trying to figure out how to mine more of it. And slag, obviously, and you can know about fly ash shortages and slag shortages, I'm sure, in different states. So obviously we've used that to the point of ad nauseum where we can't get any more. And part of that is we've been reducing our mining footprint. We've also been reducing our carbon footprint. And I think this is really the introduction to any sustainable materials management document we put together. One is we're not mining anything when we reuse stuff, and two, we are obviously reducing the carbon footprint. And those are two themes that have to really shine through in our industry. Okay, and so I talk a lot about in our classes, what about SCMs and what are we doing with those? And that's obviously that can be a couple lectures in either class. But what I want to do now is move on a little bit into more of the environmental aspects. And so I'm going to talk about MSWI and WTE, and I'm going to use those interchangeably because we basically use those interchangeably. But what those are basically using a solid waste residual, garbage, and then that is burned, and then the ash from that is a residual that we can reuse. Obviously, when it's burned, that becomes energy. And in Florida, we have a lot of facilities that are doing this, and we're not sure if we're going to see a lot more doing it, but we know that these 12 facilities are monofilling a lot of ash each year. And one of my goals is, I'll show a picture of the landfill in a little bit, is as we look into sustainability, as we look into beneficial reuse, I'd like to think of landfills as mines. They're industrial mines, they're ugly, they smell bad, but they are mines. And, I'll talk about the Pasco County landfill in a little bit, and there's a series of time between the 70s and 90s where they didn't do any metals recovery, not just ferrous metals recovery, any metals recovery. And there are some folks that want to mine that landfill. They figure it's about $50 million worth of semi-precious metals, precious metals, and then ferrous, depending upon how that goes, and illuminates. So, I want people to start getting into that mindset that all of our waste materials are really a potential for a new resource. And so I'm going to spend most of the rest of my lecture talking about this one application we did here in Pasco County, Florida. Basically, it's a small test roadway that was constructed on the site of a landfill for waste energy ash, and it's got a little bit of press, and I'm sure you saw, right, in the Pasco County Press, the Reuse Road article. Just kidding. And so this is the monofill, and there's a number of these throughout the property that's owned by Pasco County, and we basically we're using fresh waste. So anything that I've talked about right now is fresh waste. We're getting into mining next. And so the idea is, can we mine this stuff? Can we reuse this stuff? And what are the benefits to that? Well, in Japan, they do a lot of this. They reuse waste to energy ash for everything. And so you have a 3-acre site. I don't know the exact volume of it. And that's 100,000 residents over 15 years, and that is their footprint of waste. I'm going to just let that sink in for a second, because this slide, I've stared at this slide. I actually drew that poor border myself one night and prepared class slide lecture slides. But this is impactful, and this is what I think we should be doing in the U.S. The folks in Japan are doing it at a much accelerated pace because, well, they just don't have as much property as we do, right? And we tend to say, we got plenty of property, we'll just go ahead and throw that stuff away. And I really want to get away from that. Okay, so what is municipal solid waste? Basically, it's all this garbage is put into a big pile, we try and homogenize it, mix it up, and then that stuff becomes burned. And so we have we have a second boiler, that shouldn't be there. But we have a boiler here, and basically we have baghouse, that's fly ash, and then we have bottom ash. And the bottom ash and some of the fly ash can be potentially reused, or it goes into the landfill. Okay, and what that fly ash and bottom ash looks like, fly ash looks just like fly ash. Now, fly ash is a little bit more complicated because it is a hazardous waste when it comes out of the waste energy ash plant. Bottom ash is about 80% of the residual. Fly ash is about 20% of the residual. And what most plants do right now is they combine them. You get what's called combined ash. The big problem with combined ash is that does not recycle nearly as easy. So we have issues with trying to recycle both. Okay, but we are using bottom ash for a lot of recycling. So one of the things that's nice about Pasco County is they're separating bottom ash from fly ash, so we don't get combined ash. From there, we often want to get it into different fractions. And so right now, when we look at aggregates, we look at our fraction between 3/4 and 3/8 of an inch. And if you look at that stuff, it really just kind of looks like a ugly, porous, maybe recycled concrete. It looks a lot like concrete. And a lot of it, what is at the bottom of this stuff, the bottom of the barrel when you talk about burning waste? It is concrete materials. It is slag materials. It's stuff that doesn't burn very well between 500 and 1,000 C. And so there's also magnetic solids in there and other things. There's some aluminum. There's and so what does that look like in an elemental composition? Well, we got some aluminum in there, and that can be a potential issue, but it also can be compatible if we want to use it as a kiln feed. Chlorides, everyone wants to know what's going on with chlorides. Is this stuff going to make my rebar corrode? And the answer is, if it's not washed, yes, it will, as an aggregate. And then what's going on with alkalis? Do we have to worry about that sort of stuff? And the answer is, we should keep an eye on that as well. And so when we go from there, and this slide's these are not the slides I wanted, but anyway, when we get into risk, we have what are the TCLP procedures. So basically, this is the environmental engineering aspect of what we're doing. Are these concretes and materials that we make with our different waste to energy ash going to leach? Are they going to basically release toxins into the environment? And so we've done a lot of work with that as well. Again, things I don't have a lot of time to summarize. And so what I want to do is talk a little about one of our, it's kind of my favorite project, I think. And basically, it's a project where we did a number of test strips of roadway, where we have ash base, and then we have hot mix asphalt, and then ash as coarse aggregate in the hot mix asphalt, and we have a control concrete, and then ash for coarse aggregate in the Portland cement concrete. So, and with that, we've done groundwater modeling to see how that's affecting the groundwater. And really, we're not getting anything in there. So when we think of hot mix asphalt, we all know that. I'm sorry I have to show the black stuff too, but if we're going to talk about beneficial reuse, I can't just limit it only to concrete in our class. I do tell people that the good part about asphalt is it's black, it's sticky, and it smells, and if you want something to last about 10% as long as concrete, you should use it. And so when we get into our concrete, this is the road we built there. And then we also used ash base. And so basically taking that ash with the finer fraction as well, not just a coarse fraction, and using that as a road base. And what we find out is gradation of the finer material in a base material is important. You can't just go with coarse because it just won't give you the same, in our case, California bearing ratio, but we use lime rock bearing ratio in the state of Florida. And so what does that look like? Basically, that's our roadway. And the funny part about this roadway, I have a couple minutes, is when we built this, we were told, don't worry, Chris, we're going to never run trucks on this thing. You might see 3 cycles of any sort of easels per year. And I was like, fantastic, I could build a road that'll handle that. And then they decided, oh, there's a project up on I-75 north of us, and we got to truck in all the fill because they need fill to cover up landfills. And we're going to truck that through this road. So it got about 30,000 cycles in the first year. And we've done a number of visual inspections of the roadway, and there are no issues. Now, getting back into a little bit what Matt was saying and a little bit what I want to talk about to wrap up here, and that is basically, LEED and Green Building Council kind of drives the bus when it comes to us thinking about sustainability, reuse, and so forth. And, they are the driver, as I said. One of the things I've been talking a little about today in the sustainability committee, and I want to talk a lot about at ACI, is I see a lot of cradle to gate definitions. So what is it like when we get this thing here? And Doug Hooton was telling a story this morning about a timber building that's being built in Toronto, 14 stories, and it's because it's more sustainable than concrete. Meanwhile, they're shipping the lumber from British Columbia. So I say we as an industry should be focusing more on to site or to construction, because that's where we make our money. Because the fact of the matter is most ready-mix operations are relatively close to the site, especially when I consider something from going from British Columbia to Ontario, especially after listening to the folks in the 301 committee before I got here argue over how long concrete will last in a truck. And so another aspect of this is when we start thinking of concrete, cement, and so on, it is on the lower portion of the embodied energy scale. And let me just finish up with resilience. Resilience is something we're starting to get a handle on, but we're really silent on as an industry. And I think that should change because we don't really think of resilience and sustainability often together. And it took me a while to do it as well. And then Hurricane, I think Michael came through, and it basically hit the Gulf of Florida, right? The Panhandle, and a lot of homes were destroyed, so on and so forth. And so New York Times did a wonderful job saying pouring concrete, even though we placed concrete. And they said some other things that were not quite right, but at least they got the general story correct. And what is the general story? The general story is, well, you can see what's not there, and that's every house that was destroyed, not made out of concrete. And then you have the one house, well, the 2 houses made of concrete, and hopefully a very thankful neighbor hanging out behind that guy, right? I mean, beer doesn't quite get you there, right? I mean, that's like a car, and I don't know what else you give that person. But the real question is this. I mean, how much additional embodied energy was required to build this house? And how much embodied energy is required to replace the rest? And this is the part I really want to start moving forward with ACI. And I'm actually going to leave the slide here. This is the end of my talk now. So that's all I have, and thank you very much for your attention.